So I have somebody that says March 2011 would be fantastic. Questions 1, 2, 3, 4, 5, and 6. I guess that's all the questions. Okay, we could, I guess, look at them. And I have another one that says this question is worth minimal marks and hasn't appeared in a number of years. Can we go through March 2011 question 1? Okay, so I think both want us to look at the March exam.
And that's what we were intending to do once we dispensed with anything else regarding instrumentation, testing, and utilization. So there's a paragraph of preamble that explains the notation. We basically have two campaigns which are adjusted, and you should be able to recognize those. For instance, the usual least squares formulation, observations, residuals, design matrix, and estimated coordinates. The second campaign is here. If we have the same points in both campaigns, we can take the difference between coordinate values, that's x2 minus x1, where x2 is later than the x1. And so that's the displacement from coordinate differencing. And usually when we do monitoring, there are points of interest, say the points on a sensitive structure like a power dam or something. And then we have reference points which are hopefully beyond the area of influence, and they create the continuity from campaign to campaign. So we have object points, points that our figure are probably moving. That would be the displacement components there, and reference points which we hope are not moving. So that down to here is the coordinate differencing. If we have exactly the same observables in both campaigns, then we can take the differences between them. And that's the observation differencing, which is this process here. Later campaign observation value minus the earlier campaign. And if we go through the theoretical development, we can take that vector and do this through the same design matrix as we have up here, because it's the same geometry and the same observables. We can actually estimate displacement values coming from observation differences. So here we have displacements from coordinate differencing. Here we have displacements from observation differencing. This can only happen if we have exactly the same observables in both campaigns. And that's basically dealing with Part A. What are the advantages? Well, if we go into it, in order for an individual campaign to be adjusted, we have to have configuration to do that. So that means every point has to have at least enough connections to be able to calculate the coordinate values. We can't have any hanging points at all. No configuration defects, as they call it. However, we do have an advantage in this because it provides us with a knowledge of how well the campaign, everything fits together, as we would in any campaign adjustment. We don't have that when we just do the differences down here. We don't have that when we just do the differences down here. The advantage in this particular approach is that we can use observables that are repeated, but not necessarily with a closed configuration. So we can have just hanging distances and all sorts of things. As long as they're repeated, we can still take them through the deformation displacement component calculations. This then develops into the fact that we can also then incorporate geotechnical information which is basically differences in values. Like an extensometer is basically distance differencing device. And that's basically what we mean by the in question C. D part becomes a concern if we do things over a long period of time. How well have the observations been faithful to things? For instance, if an EDM scale is changing, or if geotechnical instrumentation is wandering, then how can we deal with that as the time progresses? And then E part is a little difficult to explain with just words. It's a lot easier to do with a diagram. But there are some suggestions in a couple of Chernovsky's papers on how you would use a plumb line. And that's actually now part of the engineering surveying, which would be in the next session. So I'll maybe put together some diagrams for you in that one. And the next question is really more for the fourth session, underground surveying. But if we read through it carefully, it's basically dealing with the gyroazimuth, which could be a problem almost anywhere, and that's the effects of meridian convergence. Question number 3. This would be answered to some extent through the urban and surveying and mapping discussion by Blackhout and Chernovsky and C.S. Des Moines, and it's also illustrated quite well in the Surveys and Mapping Branch 1978 publication, Specifications and Recommendations for Control Surveys and Survey Markers, in the vertical control portion. In very general terms, the concept of control, if we have points of known position, whether it's horizontally or vertically for benchmarks, the higher precision is over a greater separation, and we assume that if there's a higher precision, there's due care, and therefore there's also been a higher level of accuracy. The positions are densified with the next order down, where the next order is forced to fit the higher order, more dense but less accuracy to them. And then again, that second level controls the third level, and the third level controls the fourth level. So usually in a municipal setting, there might be 3 or 4 levels of control down to the benchmarks that you would actually use on a construction site, which leads us into, to some extent, into the B part of the question. One thing that we have to understand is the phrasing that's in this vertical control publication. The numbers that are given, which are also reflected in the formulas, there's a large delta and then an F/B towards the bottom. Maybe I'll just go to those. These expressions here are taken directly out of that Surveys and Mapping publication. They are allowable discrepancies between forward and backward leveling. They're not standard deviations of height differences. So you have to take that and convert it into a standard deviation of the height difference between 2 benchmarks.